Sigjep and Olivia. Don't miss anything. So that was 15. Any other comments, questions, concerns about any of the homework I assigned unto you on Thursday? Hoping those of you who didn't get a chance to get it done between Thursday and Friday were able to get it done over the weekend. Anybody else? Anything? 11, 12, 13, 14, 15. We're good? Kyla and Rebecca, you guys were able to take a look at the video? Actually, no, you were here on Friday. No, you were here on Thursday. Yeah, so you didn't need a video. Who are my absences on Thursday?
I'm still.
You got.
I didn't get to finish that. I was.
You're busy again.
Okay. On Saturday and then I overslept.
Slept all day Sunday. Here we are Monday.
Yeah, it was
tragic.
And
so you've got some stuff to go back and take a look at.
Yeah.
Okay. Hearing no other issues, you guys are ready for the quiz? Yes. Are you ready for it? Why aren't we ready for it? How, if there's no questions about the homework, how are you not ready? If you're not ready, that means there should be questions.
Let's do 13.
What is your question about 13, Danny? And don't say my question is how to do it.
My question is how let's see.
Okay, there isn't actually a quiz today.
Okay.
But the quiz is coming very shortly. Okay, so again, I didn't give you guys answers to the homework because I posted the keys online. So I'm assuming those of you who aren't coming with questions have done this and get it, because it is your responsibility to do the things and then to tell me you don't get them, to tell me what you want me to do for you, to help you. So if you're just hanging in the wind, I need to know. I will happily assist you get out of the wind.
Okay.
But if you don't tell me you're hanging in the wind, things are going to get real painful real quick here. You just got to let me know. I'm willing to help you as much as you want. But you need to let me know you need the help. This is the beginning of, kicking the baby birds out of the nest, and I'm not looking down. So you just got to let me know if you splat or if you're flying, because I'm just going to keep looking to the horizon. Okay, here we go. So next lesson is this. Jump to lesson 4, graphing horizontal and vertical lines. And if you notice, we're going to look at matching graphs and equations, and then we're going to use graphs to estimate values, and then we're done. So we've only got 3 lessons left. This chapter is going to be done this week, which means you got a test coming soon. Trig.
Are we going to have time to do any after that? Or?
Possibly. Why? What are you wanting?
I don't know. I just was wondering.
Okay. Yes, trig is after this.
What does trig stand for?
Trigonometry.
Okay.
You do have a final exam. I haven't decided yet. Trig is usually the last unit that I teach. You're not memorizing. No, see, that's something. You weren't supposed to memorize anything. You were supposed to learn and absorb the skills into who you are, so that I just slap the test down, and it just is an extension of who you are. Yeah, you're right. That's not a skill. That's not a skill. Okay, everyone's talking too much. Yes, Kyla. It is currently, it looks like it might be me for Predip 10, but it isn't 100% me, but it's like 90% me. What units are going to be in it? Oh, it's students are going to be in it. I have seen the lists. I have not seen the most updated lists, but I have seen... No. Okay, why we can don't worry about next year. Next year will deal with itself. Next year will deal with itself. Presley.
Have you set or not request, but have you approved people for pre-diploma next year? Can you when do they do that? Can you go no, not them?
That is something we are constantly doing. I did it a couple weeks. But you guys, it's hard because they asked me to do it right before I got to know any of you guys.
Right.
Mr. DeVries actually came to me a month ago and said, "Here's the lists. What do you think?" And I was like, "Yep, nope, yep, nope." And that was just how it went. And then I was like, "Oh, there's a bunch of people I don't know." And then I said, "Oh, if this person works really hard, then yeah, they can totally do it. If this person continues to not work hard, then maybe they should not." But these are all conversations I'm going to have with you before the end of the semester. I will sit down with each and every one of you, and I will say, this is what's coming at you. This is what I recommend or don't. Okay, I will have all of those conversations with all of you. Last week of school, don't worry about it. Okay, relax. Lesson 4, here we go. It's going to be tests. It's going to be great. Okay, so I'm still recording. So whoever is away and is going to get this video, they're going to be like, when does this lesson actually start? It starts right now. So there are, ladies and gentlemen, thank you. There are a few specific kinds of special lines that screw people up. And so we devote a whole lesson just to these really simple looking lines that for whatever reason people don't do well with. So here we go. We're going to graph purely vertical and purely horizontal lines today. Up to this point, all of our lines have been kind of askew. Left and right and up and down and kind of at an angle, but nothing just perfectly up and down and nothing perfectly left and right, so that's today. The graph of an equation that looks like this, x equals a. What is going on with a graph that looks like x equals a, where a is constant? So for an example of this would be something like x equals 3. I tell you that it's a vertical line, but why is it a vertical line? Like what's going on there? If I tell you x equals 3, what do we do? Or what does that mean on the xy plane? Okay, we have an xy plane there. If I tell you x equals 3, where is a point on the line x equals 3? You go to x, okay, cool, and you go over to 3. When I tell you x equals 3, what haven't I told you? I have not told you what y is. And if I don't tell you, in the context of a graph, what something is, what you're going to assume is that everything's okay. Okay? So, if I tell you x equals 3, y equals literally anything. So then what other points are going to be on this graph? The one that I've drawn here is what point? 3, 0. But in order to draw a line, I need at least 3 points. So what are 2 other points if y is allowed to be anything and x has to be 3? Okay, that's great. Give me. Okay, so 3, -3? Sure. That's going to be down here. 3 in the x, -3 in the y is going to be right there. Give me one more point. If x has to be 3, give me something up here. 3, 4. Sure, that's going to be up here somewhere. And once I've got my 3 points, what do I do with them? I connect the dots. So what does that line look like? Well, that thing is just a vertical line. Every point on the graph has the x-coordinate 3, and y can be literally anything,
Every point.
given my specific example.
Okay. You knew that you would write down x equals 3 above there.
Well, that's what we picked.
Or
I would
you
have
could
just
write
put in whatever values. If we go back to the original that I have there in orange, I can say the x-coordinate is, I'll put it in brackets, a, whatever a is. So if x equals 5, what's that line going to look like? It's not going to be exactly the same thing. Yeah, if I'd picked, so let's do it in pink here. If I've got x equals 5, what's that line going to look like on this grid? It's going to be over to the right, yeah. But it's going to look, that's supposed to be straight up and down. My apologies for not using a ruler. That's the line x equals 5. Because the implication there is if I don't tell you what y is, it can be everything. So there is no hint. It just is that. It's just that easy. So then we're going to determine the equations for the following line. What's that? It's not just 2. It's x equals 2. What's this one? X equals -3. Cool. What's this one? Love it. See, this is not overly difficult, yes? The thing that happens is we like, oh yeah, this is easy. And then, in 4 or 5 days, you're going to write me a test, and you're going to be like, yes, x means horizontal, so the horizontal line is going to be x equals whatever. And that's exactly where you're going to get screwed up. Because x equals, yes, x-axis is a horizontal line, but when x equals something, you want to make sure you're deliberate about what you do. You go to that point on the x-axis, you put your point there, and then you start to adjust y. It's the adjusting y that's going to give you the verticalness of a line, x equals whatever. So let's draw these graphs. X equals 3 we've already done. What's it going to look like? I go 3 over to the right. And what do I do from that point? Straight up and down. How about x equals -2? On the x-axis, I go 2 to the left. Straight line up and down. This guy? X equals 0 is going to be what line? It is going to be the y-axis. Absolutely. Straight down the middle. It's really that straightforward. People get messed up when they think, oh, x. X is the horizontal axis, so x must be a horizontal line. Boom.
Oh, I see.
That's the mistake people make, and that's not what's happening here. If I tell you x is a particular value, that coordinate is not allowed to change.
Just think x is closer to D in the alphabet than it is to
That wouldn't help me in the slightest.
It's vertical and
So maybe there is a hint I should give you here.
x equals
Also, no, do not listen to Danny. The x-coordinate doesn't change. Y does. And it's the changing y that gives you the verticalness. Instead of thinking about, okay, well, if x equals 5, let me draw my horizontal line because x is horizontal. Think about what is allowed to change. X has to be this, y changes. That's what gives you the line. It's the changing that gives you the line to draw. So then, if I wanted to draw a horizontal line, what variable am I going to keep the same? I'm going to keep y the same, and x is now going to be allowed to change. So let's go down to the bottom of this page. Graphing horizontal lines now. The graph of the equation y equals a, where a is constant, this is going to give you the horizontal line, y. And that's a question, not the letter. Why does y equals a give us a horizontal line? Because the y coordinate doesn't change. Because we've defined it to be a particular value.
Why do you put a dash between the y coordinate? I don't understand. Is there a reason?
Because some people, if I don't specify that it goes with this, there are, based on how I write, sometimes my writing is a little close together. They'll be like, they coordinate. What?
Oh.
Like, no, the y coordinate. Just it helps me emphasize how I say it.
Oh.
And it helps people, especially people who aren't here, or the few of you who actually go back and look at your notes after we do them, to help you with your homework, because I know that's not a very common thing to do. Can be like, oh yeah, that's what that meant.
Okay.
So the y coordinate doesn't change. X does. So if I tell you the point is y equals a, the y coordinate is going to be a. Thank you, whoever said it. So I'm going to have a whole bunch of coordinates that are going to be bracket, comma, a, when the x coordinate is allowed to be whatever. And it's the fact that my x is allowed to be whatever, that's what's going to stretch us horizontally as far as we want to go. So this graph here is what? What is the equation of that graph? That's y equals 3. This one is, ooh, that's a good one because it's actually that line there equals -1. Love it. What's this one? Y equals -2. Cool. Flip the page. So let's graph these guys. Y equals 1. What's that going to look like? I go up 1. I draw my line. Cool. How about y equals -1.5? It's going to be between two lines. It's going to be between which two lines? No. -1 and -2. So it's going to be right here. That's supposed to be flat and straight, but it's not. My apologies. And then y equals 0 is what line? It is the x-axis. Good.
And axis is spelled with the IS, right?
Yes. Plural is with the ES.
Right. Okay.
Axes.
That's a very obvious line.
When yes, I'm over exaggerating it for a reason. Yes.
Okay. Wow.
Because when you're on an axis, I really want to make sure you guys see it.
Okay.
As opposed to, when you guys are doing a test or a quiz, you need to make sure that I see it.
Yeah.
So don't just draw me a thin little line over top of the axis. Like, is there a pencil there, or did they just not do the question? I don't know.
Yeah.
So that's the horizontal, that's the vertical. Things get a little bit more, things are way more interesting when we draw the oblique lines. Oblique, this word means slanted. Gentlemen, these are the askew lines. Askew. Oh, oblique. And these are not the muscles, your obliques. This is like the oblique, like off at an angle.
Okay. Like.
No, like nothing. Just like know that word means off at an angle. Okay. So there are a couple ways to do this, and I'm going to demonstrate to you what those couple ways look like. The graph of an oblique line has x and y in the equation. Both of these variables show up here, and that tells you that both of those variables are allowed to change. When both of those variables are allowed to change, that's where we get things that go a little bit this way and a little bit this way, and a little bit this way and a little bit this way, and give us the slanted nature of these graphs.
move fast. Yeah. I just heard a little bit this way, a little bit that way.
Yes, and if you weren't looking,
Yeah, no.
it becomes weird because I'm just doing this like L shape, and
Yeah.
let's give Jap and Olivia a headache.
Time.
Because both variables show up in the equation,
Okay.
it allows for both variables to change.
Okay.
So if my x variable is allowed to change, I might go a little bit this way. But if my y variable is also allowed to change, I'm going to go a little bit this way, giving us a point up here somewhere. The next point is going to be a little bit this way and then a little bit this way. Now, if you can picture what I haven't drawn, we've got a point up here and a point down here, allowing us to connect them into this dotted lineness.
So
Let's actually, we're going to do a specific one right here, this line.
Okay. You can just put stuff wherever you want as long as it gets to a certain point?
No,
Oh. Okay, that's what
because
Okay.
the equation, and you've done this already, this is a lesson we did last week, the relation or the equation with x and y forces us to operate within that relationship. As I do something with x, it's going to produce a change in y. If I give us a change in y, it's going to produce for us a change in x. And so there's two ways to handle that. The first one is to use a table of values. That's option A here. I don't think, yes, we're going to do it, but it's not listed here. Option A is to make a table of values. This is the standard Math 9 curriculum. When you make a table of values, you always give, or you typically, I shouldn't say always, you typically give the independent variable. And if I don't tell you what the independent variable is, I just give you x and y. The independent variable is always what? X. So I'm just going to label this guy as the ID. Typically, these are the variables, this is the variable rather that you choose. So give me a collection of values that we're going to end up shoving into our relationship. Carolyn, give me one good value. 0. We're going to slam it right there in the middle of my chart. Why did I put it there? Because I want some negatives, I want some positives. So someone else give me another value. 3. Someone give me another one. -3. Do I need more than that? You only need a minimum of 3 points. The reason I put the negative up at the top is because typically what we do is we write these things in increasing order going down. My first entry is going to be my lowest number, and -3 is lower than 0 and 3. So the negative value typically is what's going to show up first. Then I'll have -2, -1, 0, 1, 2, 3. So let's do it. This is the relationship we're going to use, because that's the question. And I want to insert values for x and figure out what y is then going to have to be equal to. So let's do them, all three of them. If I take my value here and I insert it into this equation, this is what we did 2 chapters ago. It's going to be 4. I'm going to put a set of brackets down. I'm going to shove my value in there for x, minus 2y equals 4. And now I'm going to solve this thing for y. How do I get y by itself? So it's going to be -12 minus 2y equals 4. Okay, what next? I'm going to add 12 to both sides. Cool. So I'm going to get -2y equals 16. To get y by itself, I'm going to do what? -2 divided by -2. I'm going to get y equals -8. So my first point on the graph is going to be this point here, -3, -8. Where the heck is that point? Is it even on the graph? We're going to go, where is that point going to be on this grid? From here, what do I do? 8 downwards. 1, 2, 3, 4, 5, 6, 7. Oh no. 8. It's the next line underneath our graph. That's okay. We'll make do. And then I go which way? 3. Which way? Left. 1, 2, 3. So it's going to be that point kind of there. That is the point. -3, -8. Okay, where's my point 0 going to be? It's going to be on the y-axis, good. We don't know that, though. Oh, sorry, no, we don't know that it's going to be on the y-axis. We know it's going to be on the x-axis. Actually, no, I lied to you again. We know it is x equals 0 is which line? No. X equals 0 is which line? It's the y-axis. So this point here is going to be on this axis somewhere. We're going to figure out where. So I'm going to take my value for 0 and we're going to plug it into this equation. So I'm going to get 4 times 0 minus 2y equals 4. Well, that's just 0. So then now I'm left with -2y equals 4. So what's y equal to? It's -2, because I'm divided by -2, divided by -2. We get y equals -2. So I'm going to get the point 0 and -2. That's going to be that point right there. Who have I lost? Other questions? Okay.
So
Danny?
you basically look at the equation and you're like, okay, I'll just make up a random thing for x, and you
No, not random. You want to be deliberate with the points you choose.
right, have a 0 somewhere in the middle and have negative and positive numbers, and have it
Like 90% of the time, yep.
That would be at least 2 points.
Yes, you are required to have a minimum of 3 points
For what? Like
to graph this line,
okay.
to verify that this thing's linear. Gentlemen, just wear your own hats and call it good. So last thing we're going to do, we're going to plug this point 3 in here. So I'm going to do that on the left-hand side here because I want to use this space down below for something else. So we're going to go 4 bracket 3. I'm inserting my x value into this equation. Minus 2y equals 4. So that's going to be 12 minus 2y equals 4. I'm subtracting 12 on both sides. Get -2y equals -8. So y is going to equal 4. So the point 3, 4 is going to show up on my graph. I start in the center, and I'm going to go over 1, 2, 3, and I'm going to go up 1, 2, 3, 4. Do these 3 points make a straight line? You bet they do. There we go. That is the regular grade 9 curriculum. Take your relation, create a table of values, graph the points. There is a better way to do this. This is the technique that the regular math teaches in grade 10. I'm going to introduce it to you now. This is option B. The equation of a line. Okay? Every linear relation has a particular form. And the form of every linear relation, actually there's a few forms that you can have. There's what's called standard form. Okay? So let's write these out. Standard form for a line is going to look like what? Well, we know the exponents on the variables for a line, for a straight line, have to be both what? Not 0, 1. So we're going to have the standard form for a line is going to look like this. It's going to be ax plus by equals c, where a, b, and c are rational numbers. So the relationship that we're given for this example, this is what standard form looks like. 4x minus 2y equals 4. This is this. In this case, a is what? It's 4. A is 4. B is, it's not 2, it's negative 2. And C is 4. Cool? Okay, so standard form. Standard form, not super useful. Then there is a form called slope-intercept form. And this is the one that I haven't actually called it that, but we've already done this. Slope-intercept form looks like this. Y equals mx plus b. Where, and I told you this already, I told you this last week, what is this m value here? M is, no. What was m? It's a ratio. Change in y over change in x. And b is the y-intercept. And for those of us who, the y-intercept is the point where the line crosses the y-axis. The coordinate of that point is always going to be, well, what's one part of that coordinate? You know it's going to be. It's going to be 0 comma something. 0 comma something. And this, and b is what that something is. 0 comma b. There is another form that I will just tell you about here casually. We're not going to use it this year. You will use it eventually. It is called point slope form. No, it's called, yeah, point slope form. It is kind of an ugly monster, but it exists. If you want to see it, I'm happy to show it to you, but I want to use the space down here to use slope-intercept form. So actually, you know, I'll make a note of it over here. There is a point slope form. Oh, dot, dot, dot. Later. Eventually, you'll learn point slope form. And the nice thing about all of these forms is that they can be transformed from one to the other. And we're going to do that with this guy here. Danny.
I have a question.
Yes.
You said y-intercept, you just covered it up now, but y-intercept equals 0 comma b, 0 comma d, 0 comma...
No, it's always, it's this b right here.
What is a b? Okay.
That's a b.
Double check.
That's a b. 0 comma b.
Okay.
From this form. So let's do that. We're going to take our equation up here. 4x minus 2y equals 4. And what we want to do is we want to turn that into, so we've got standard form. I'm just going to call this SF. And I want to turn this into SI. Slope-intercept. Standard form into slope-intercept form. Yes, Carolyn? Or she's going to do it. Okay, so Carolyn, if I want to go from ax plus by equals c into y equals mx plus b, what do I have to do first? A smart thing to do would be to add 2y to both sides. Absolutely. So 4x is going to equal, I'm going to zoom this in here so it's easier for everyone to see, 4 plus 2y. Now, why did you do that? Yeah, you want to make sure that y is alone and positive. So the smart thing to do to make, because for whatever reason, students will always screw up negatives. We forget to include them, and then we don't use them properly. So adding this guy over makes my y positive, makes our life a little bit easier later on. Next step, Carolyn? I'm going to subtract 4 on both sides. So I'm going to get 4x minus 4 equals 2y. I'm going to go up here. Last step. I'm going to divide by 2. So I'm going to get, hold on, I'm going to rewrite this up here, and then we're going to simplify it. You got to be careful when you have something like this. This is technically correct, but this is not a useful form. When I'm when I'm dividing something that I'm adding or subtracting in the numerator by a single number, I can rewrite it as 2 fractions. I can write it as 4x over 2 minus 4 over 2 equals y. And if I do that, what am I going to get? I'm going to get y equals 2x minus 2. This thing now is in slope-intercept form, and now I'm going to show you how to use this thing. With slope-intercept form, what point do we know is on the graph for this line here? No, that's not a point. What is the purpose of, 0, comma, and b is -2. So we know from this graph 0, -2 is a point we're going to draw. So we go to the point 0, -2, and oh look, it's right there. Whoops. Whoop. It's right there. Now the question becomes, what do I do with this 2 out front here? Well, this is, remember, the change in y over the change in x. If I don't have a number in the denominator, what is the denominator? It's 1. So what does this tell us? Well, it tells us that if we go 1 in the x direction, we're going to go how far in the y direction? 2. And because both of these numbers are positive, a positive x means I'm going which way? Going right. So from this point here, to get to the next point on our graph, we know we have to go 1 in the x direction and 2 in the y direction. Oh, look, that point is also already on the line that we created from our table of values. Now to get to our next point, we're going to do what? 1 right and then 2 up. 1 right and then 2 up. 1 right and then 2 up. And I don't have to make the table of values. I can make all of my points using my intercept and the slope from that intercept, and I've made my line now without having to go through all of the algebra of making a table of values. All I did, I said, well, screw it. I'm not going to do all my table of values. I'm just going to take my standard form, turn it into slope-intercept form, use the 1 point I'm given, the y-intercept, and use the slope to build my line. This is the portion of this lesson that is usually reserved for grade 10. Questions, comments, concerns with any of this? Whoop.
I don't know. I just got lost.
Where did I lose you?
Well, everything made sense when you were explaining it, but I have no idea what you're talking about. Like it opened this up and then really, and then go up to 2, and I was like, oh wow, it works. And then I didn't know. It was just like little parts I got, but I'm like, and the arrows, and I had to write it on one side of the page, and then I lost.
Then I would say go back and look at the video. And
Maybe I'll try to take a picture if I store it.
okay, so guys, just so you know what my expectations are. All I expect from you guys, the minimum you have to do for me, is be able to use the relationship to create a table of values to create a graph, which you've been doing already. Those of you who want to be a little bit more enterprising, and ultimately want to do less work, the lazy among you, and a good mathematician is a lazy mathematician. So if you want to push yourself to becoming a good lazy mathematician, jump straight from this, the standard form, solve it for y, to put it into slope-intercept form, then you've got 1 point on the graph and the relationship to get you everywhere else.
So how exactly is slope-intercept form going to be useful to us doing this? I just don't, that's the part.
Why is this useful? Because there are so many things in the world that the relationships are inherently linear. For example, traveling at constant speed. If you remember back to those word problems, when we were traveling at constant speed, we had a relationship that said, I'll go over to the side here, d equals vt. And then I gave you v. I said v is 4 miles per hour, or 6 kilometers per hour, whatever it is. So we'd have d equals 6t. Well, this is a linear relationship because both of my exponents are 1. So now I can graph what's happening with the distance and the time. Is there a plus whatever here? No, so that means my y-intercept for this graph is going to be what? What point? Well, it's the same thing as having plus 0, right? So that means if I haven't gone any time, I also haven't gone any distance. So I'm at the point 0, 0 on the graph. So my graph is going to look like this. The point 0, 0, if I haven't gone anywhere, or I have no time has passed, I haven't gone anywhere. Well, what if so then if I travel 1 minute, assuming this is 6 kilometers per hour, no. If I travel 1 hour, how far have I gone? 6 kilometers. If I travel another one, I've gone, and now I can connect those dots. Now I've got a linear relationship between distance and time. But what if it's not distance and time? What if it's, ticket sales and profit? Or what's something that you guys have done? You all should have at this point done. Here's an interesting one for you. Maybe you didn't. Maybe it didn't show up in science. How many of you have done electricity already in science?
We're working on it.
You're working on it? You have a relationship there. What's the relationship? V equals IR. That is a linear relationship. What if I graph voltage and current? What if I tell you that my current is 1, my voltage is 1, and when my current is 4, my voltage is also 4? This is a very similar form. This is y. What's x? X is, in this equation, x is I. And if I look at my form for a linear equation right here, that means that r must be m, which is my change in y over my change in x. So what I've just done here, that's my m. What we've done here, and I'm not going to require that you do this, I'm just showing you the power of this. What I'd tell you is if you are able to figure out what some voltages and some different currents are, and you can do this by measuring them with a voltmeter. I don't know if you've talked about voltmeters in science, but it's a tool used to measure voltage, or an ammeter, a tool used to measure current. If you can measure, guys, you can measure voltage, you measure current, you find the relationship between them, it gives you resistance every time. Yes, Yuria, you can go to the bathroom.
Where's the plus B?
Well, the plus B here, if I have no current, do I have any voltage? No, so then my plus B is the point 0.
Okay.
So if I don't write it, it's assumed that the intercept is 0. So there are so many relations, and you haven't seen it because no one's pointed it out to you yet. But the power of these linear relationships is that they show up friggin' everywhere. And this is the first type of relationship that you're going to look at. You're going to look at quadratic relationships and cubic relationships in the next couple coming years, and you're going to see relationships that exist there. And you likely won't make the connection in math, but your physics teacher is going to be like, see what we did? Oh, look, it connects. And you're going to be like, graphs again. Like my grade 11s are losing their mind now that they have to do graphs again. Or there's relationships between the extension of a spring and the force required to extend a spring. If any of you have ever built a trampoline, you know this to be true. The further I want to pull a spring, the harder I have to pull. Because springs are difficult to use. At least trampoline springs are. Slinkies are easy. Okay? So I know there's a lot here. All you have to be able to do at this point is this. If everything else freaks you out, stop right there and be like, oh, look, I can create some points by plugging equations into, or by plugging values in and solving them. This is 3 chapters ago or 2 chapters ago. You can use whatever method you want. So for those of you who are like, F this, I don't want to do all that work. I just want to do, basically what we've done is we did all this work here in pink once by putting this equation together. And then everything else is, that, and then change in y over change in x gives me all the points to draw the line, and now every other point is given to us using this relationship. Change in y over change in x is that value there. We call that the slope.
Right.
And this is what you are not required to do this year. But if you want to, I will not require how you graph the line. Use the table of values, great. Or you can be like, I want to save myself some work in the long run by really nailing down in my head what's going on here. So then do it.
I understand the solving for y, like that makes complete sense. But then I look at like what was MX plus B? Okay.
This is just, we did this before with the table of values. We found the ratios, the change in y over the change in x. Yeah? Hold on. Presley's question.
Would you ever need to take the slope intercept form and change it into the standard form? Like, would we do that? That's a question.
That is, if someone made you do that, it would just be it would be a cruel task just to make sure that they knew that you could. That is never a useful thing to do. This guy right here, it would be an evil test question. Do this because I don't like you. Take it slope intercept, turn it into standard form. Standard form is never useful. This form right here is the most useful form because there are so many things that exist in the physical world that are inherently linear. And as soon as you find that relationship, there's lots of information that can be derived. Everything my students have done this year for me in Physics 11, every lab we've done has been connected directly to a different linear relationship. If you can graph a straight line, Physics 11 is real easy. Believe it or not, my grade 11s can't do it still.
Physics 11 does not sound easy.
Physics 11 is easy if the advice that I give at the beginning of my Physics 11 is you have to be willing to let me reprogram everything you think you know about the way the world works.
Isn't that from a movie somewhere?
The Matrix
Yeah.
is a similar thing. That's why Physics 11 is so hard, because my students, they hang on to what they think they know to be true. And usually what you think is true is not. But that's beside the point. That's coming later. What I want you to do, I know that I have frustrated some of you by demonstrating to you this. Hear me when I say, you do not have to use this year. If this bothers you, don't worry about it. Just make me a table of value and go for it. Forget I wrote down any of this crap. For those of you who want to extend yourself a little bit and want to do a lot less work, wrapping your head around what I've done here is a really good choice. There's 15 minutes left. I'm going to assign you your homework. This point where it says let's practice, this is part of your homework. Okay? Nice and easy, relatively straightforward. One sec. This one down here, or y equals mx plus b. I don't care, you choose. This would be a really easy one to try this, to wrap your head around it. Nice simple little equation. Nothing scary. In fact, it looks a lot like the one I just did. The only thing is, instead of 4 and 2, it's 2 and 6. Everything else is exactly the same. This would be a lovely one to try. And then there's a bunch of questions in here I want you to try. It's 1 to 12, 13, 14, and 17. There is no 17. That is a good point. Then you don't have to do it. It's not there. Nope, it's gone. 17 you cannot do. I want you to, and use this time. You can get a lot done in these next 15 minutes. Yeah. Okay. Be free to work. I will help whoever wants it.